Okay, so I can actually test that with unit test cases, right? So I can check that list to number of the list, 5 to 1 returns 125, right? And I can check that the number 125, if I turn that into a list, I get 5 to 1, right? But here's something that I can do that's even better, and that is to actually do a little theory, right? So what this says is that if n is a natural number, okay, then that should imply that when I go to number to list, right, to digits of n, I should just get back n, right? So that tells us that those two functions are inverses of each other. I believe that's true. Okay. Now, just to be clear, I need n to be a natural number because this isn't true for anything else. For example, if n is equal to pi, like I said, we'll actually return 0 from the list of digits. So it's clearly not going to work. But anyway, let's see if we can prove this. Okay. And don't forget that ACL2 is not just a programming language; it's a proof system. So we can actually try. All right. And success. Okay. It actually generates lots of random tests, and of course they all work. Okay. Now let's go in the other direction. Let's start with a list, convert it to a number, and then convert that back to a list. I should get the same list. That actually doesn't work, right? Suppose that I start with a list ABC and I convert it to a number. I don't know what I'm going to get, okay? But I'm going to go on a wild thing and say that it's 0. Well, when I convert 0 back to a list, I'm going to get nil. I'm definitely not going to get ABC. And in fact, notice that no matter what list to number does, there's no way to go from that number back to a list and get ABC. Okay, so what we need to do is just talk about list of digits. Maybe those are the only ones for which this works. And oh dear, remember that when we take a number and we convert it back to a list, it never has a leading 0. So we have to make sure that when we start with a list, we have to start with a list that does not have a leading 0. Okay, so let's define that type. Okay, and the first thing I'm doing is I'm defining a digit. Okay, and this is the syntax. We haven't seen this before. Okay, this is the syntax for defining an integer that's in a given range. Okay, so I have an integer that's in the range 0 is less than or equal to, that's the underscore, that's the number that we're defining, less than 10. So what this means is the digit has to be an integer in that range. So digit is 0 or 1 or 2 up to 9, right? Because those are the only integers in that range, 0 up to 10, but not including 10. Okay, and now we'll define a digit list, okay, to be simply a list of digits. So for example, that includes 1, 5, 7. It also includes 2, 3, 0, 1, 0, and so on, right? It's just a list of digits. By the way, it also includes nil, which is the empty list, so it's a list of digits. Okay, so that's what we define. We now define this type, and now we should be able to state our theorem, right? This only works for that. Except the leading element can't be 0. And remember, the leading element is the leading element of the numeral, and the way that we define things, that actually comes at the very end of the list. So we can do that, and you remember the function last, okay? That gives us the last element of the list, but actually gives us a list containing it. So here's 1, 2, 3, 4, and this is what last does. It gives us a list containing 4. Last of nil is just nil. That's good, right? Okay, so that's almost what we want, but not quite. So what we actually have to do is look at the first element of last. Okay? The first element of the last of a list actually is the last element of the list. Okay, so here's what we have. We want to check to see if I have a list of digits and the last digit of that list is not equal to 0, okay, not equal to 0, right? Well, then it should be the case that if I take my list and I convert it to a number, and then I take that number and convert it back into a list, I get back the very same list, okay? And this is something that it can test, right? And it tests that using, random random generation of inputs, and this is a true fact. So no matter what inputs it randomly generates, this will always be true. So I won't find any counterexamples, and it says yes, I believe that.